Good afternoon, madam. This is my teaching aids for lesson plan 2, 3, and 4. First of all, this is my chart for lesson plan 2, which is precipitation reaction. This is one of my teaching aid, and the second teaching aid is my lesson notes. My lesson notes, which is the one that I've sent through Dropbox. And my third teaching aid is this short video, which is based on precipitation reaction. It is an experiment of precipitation reaction.
Right, we're going to do a precipitation reaction. We discussed precipitation in the identification of anions, and now I'm going to show you how to do a simple precipitation reaction, which is also a double displacement. So we're going to take one compound, here copper sulfate, lovely blue colored crystals. Copper salts are very, very interesting and colorful, whereas sodium carbonate here, is boring and white, like 100,000 other powders. But when we mix them together, we should have something interesting happen. So I'm going to take a little bit of copper sulfate in a spatula, put it into the test tube, and we're going to add a bit of water to that and dissolve it. So let's just swirl that around until we've dissolved it. It should form a nice blue solution. And while that's busy dissolving, I'll do the sodium carbonate. So we take a little bit of that, we put that into the test tube, and we do exactly the same thing with a little bit of water. And we swirl it around and try to dissolve the sodium carbonate. So we have two solutions here, and what we're going to do is pour both of them through a filter funnel with filter paper in it, and we will get a precipitate, and then we'll get a solution. Here's the filter funnel, and I'll show you how to fold one of these. You take a piece of filter paper like this, you fold it in half, you fold it again into a quarter, so now it's like that, and then you've got something like that. Put that into the filter funnel like this. So, solution of copper sulfate, solution of sodium carbonate. We're now going to combine the two of them. And you can see we've already got a precipitate. There's a solution in there, and there's also something that will not dissolve. And we're now going to pour it through the filter paper, which means the solution stuff will go through, the precipitate will remain. It might take a little while, so we'll come back to it. So basically, the copper sulfate becomes copper carbonate, and the sodium carbonate becomes sodium sulfate. They swap partners, in other words. And this is mostly sodium sulfate at the bottom, and this is copper carbonate, which is a precipitate, which you'll see doesn't dissolve in water, and the filter paper's captured it there very nicely, and it's very blue. So you can see that that's it's even a different kind of blue to the color of copper sulfate. So it's a whole different compound. We call these double display.
So that's all for the video for precipitation reaction, and also I have done a setup or experiment during my peer teaching too, which is on calcium carbonate and hydrochloric acid. Moving on, this is my chart for lesson plan 3, which is states of matter. I've done the model on these three types of matter, which is solid, liquid, and gas. In solid, we can see that it is packed together. There is no space, and in liquid, there are space. There more space in them. They are far apart, and on gases, they are much far apart. Okay, that's a model on the states of matter. Okay, and plus the lesson notes of lesson plan 3 that I've already sent, and also a short video on matter, which is from YouTube. Here's a short video on matter.
this video you are going to learn what the three states of matter are, some examples of each state of matter, the characteristic properties of the three states of matter. The three states of matter are solid, liquid and gas. Let us look at solids. An example of a solid is your computer. The properties of solids depend on how the particles in solids are packed. In a solid, the particles are closely packed in fixed positions and cannot move anywhere. So, solids are rigid, cannot be squashed or compressed, have a fixed shape and a fixed volume. They cannot flow. Now let us look at liquids. An example of a liquid is water. Just as with solids, the properties of liquids depend on how the particles in liquids are packed. In a liquid, the particles are again closely packed, but not as closely packed as in solids. So this means the particles in liquids can move around each other. So, liquids are not rigid, but because their particles are closely packed as in solids, they cannot be squashed or compressed. They do not have a fixed shape, but they do have a fixed volume. Beware with that one, as many students think because liquids do not have a fixed shape, they do not have a fixed volume either. But they are wrong. If someone orders a pint of beer, they cannot make it 2 pints by pouring it into different containers. As you know, liquids can flow. Finally, let us look at gases. An example of a gas is helium. This is the gas in party balloons because it is less dense than air and unreactive. Again, as with solids and liquids, the properties of gases depend on how the particles in gases are packed. Unlike solids and liquids, the particles in gases are not closely packed, they're far apart. As a result, gases are not rigid and can be squashed or compressed. They do not have a fixed shape nor fixed volume. They fill the whole space they are in.
Okay, that's all for the video, a short video from YouTube for lesson for the topic states of matter. And this is my chart for lesson plan 4, which is the calculation on acceleration, velocity and speed. There are different formulas that is being used to calculate the questions that's given on acceleration, velocity and speed. And also my lesson notes, which is already been dropped on Dropbox. That's one of my other teaching aids, and a short video on YouTube based on acceleration, velocity and speed. It's a 2 minutes video.
Thanks for stopping by. I'm Virgil Ricks, and this is 2 Minute Classroom. Today we're talking about motion. Specifically, we're talking about speed, velocity, and acceleration. And let's clear up a few things right off the bat. First of all, speed and velocity are different, and acceleration is much more than just speeding up. Speed is the rate at which something changes its position. It's represented as distance over time. Miles per hour, kilometers per hour, meters per second. These are all examples of the units for speed. So if you're driving in your car at 72 miles per hour, then that's your speed. In fact, it's your instantaneous speed, or your speed in that exact moment. If you get to the end of your trip and realize that it took you 2 hours to drive 120 miles, then your overall speed was 60 miles per hour. And this is also known as your average speed. Velocity is a lot like speed, except for one important difference. It's a vector, which means it has a direction attached to it. So while your speed may have been 72 miles per hour, your velocity was 72 miles per hour east, or 72 miles per hour towards the beach. There just has to be some direction attached to the speed to make it a velocity. With that knowledge in hand, you're now ready to understand acceleration, which is simply the rate at which velocity changes. It's represented as distance per time, or distance per time squared. For example, meters per second squared are common units for acceleration.
Anytime you change your velocity, you are accelerating. That can be speeding up or slowing down, which is also known as negative acceleration. But direction is also a component of velocity. So when you change your direction, even if your speed doesn't change, you are accelerating. Does that blow your mind? All right, let's recap. Speed is the rate at which something moves, distance over time. Velocity is speed with a direction, so distance over time with a specific direction. And acceleration, the king of them all, is distance over time squared, or the rate at which velocity changes. So whether you're speeding up, slowing down, or changing directions, you're changing your velocity and thus accelerating. Science is so cool. I hope you enjoyed this video. Feel free to throw any comments below.
Thank you. That's all about the short video for lesson plan 4, which is from the YouTube. And that's all for my teaching aids for these 3 lesson plans. Vinaka.